The question here is, what is the 2:1 approximate method? Say we have a rectangular footing of dimensions b times L. This footing supports a column load of P, and P is related to the footing pressure by this equation, P equals Q times B times L. Say we are interested in calculating the change in the vertical stress at a point that lies on the center line that goes through the foundation and at a depth of Z. What this method says is the following. The method says on the surface the footing loading P is carried by this area right here, B times L. Now you go down to a depth of Z, the same loading P is now carried by an n-large area, and that n-large area is calculated using this 2:1 rule. Since this distance is Z, by this 2:1 rule, this distance becomes Z over 2, and similarly this distance is also Z over 2, and therefore B becomes B plus Z at a depth of Z, and similarly L, which is the length of the footing in the direction perpendicular to the paper, becomes L plus Z. And therefore the vertical stress at this point is simply Q multiplied by B times L divided by the area of this enlarged part at the depth Z, which is B plus Z times L plus Z. Or simply the column load P divided by B plus Z times L plus Z. As an example, let's say we have a column load of 400 kilonewton carried by a rectangular footing of dimensions 2 meter by 3 meter. We are interested in calculating the change in the vertical stress on the center line at a depth equals 1 meter. Just for comparison, let's first calculate the surface pressure, which is 400 divided by 2 times 3, which is the area of the footing, right? So it works out to be 66.67 kilopascal. Now using this formula, we calculate the change in the vertical stress at a depth of 1 meter, which is 400 divided by B, which is 2 meters, plus Z, which is 1 meter, times L, which is 3 meters, plus Z, which is 1 meter. And this gives us 33.33 kilopascal, so basically half of it. So this is what is called the 2:1 approximate method.